Alright, so I got sent a good question that I thought would be good to go through because it talks about domain and ranges of composite functions, which is not something that comes up often. My number one tip is actually look in the textbook for this topic. It can actually be helpful. We've got given two functions, f of x and g of x. Now our task is to work out the domain of the composite function. Well, first of all, we've got to work out what the composite function is. So g of f of x, well, all that means is g is the outer function and f of x is the inner function. Now, g of x is log e of x, but wherever we see an x in g of x, we're going to substitute in f of x. So our new function is going to be log e of x squared plus 1. Hopefully that's not too crazy. The next part's the hard part. Now we're going to think about the domain of the new function. First of all, let's look at this red curve up here. This is f of x, x squared plus 1. I encourage you to fill this in before me. See if you can fill in this table. So the domain of f of x is going to be all real numbers because it goes from negative infinity all the way to positive infinity. Now the range is going to be, well, from 1 all the way up to infinity, 1 inclusive because it touches the point 1. Good, so now the other line we have is g of x. Now, the domain of g of x is going to be 0 to infinity because we go from 0 all the way over this way, and the range, well, we go all the way down to negative infinity and then we go all the way up to positive infinity. So the range is all real numbers. Now, the next thing we need to think about, so this table is useful, the next thing we need to think about is this, and this has to be true for composite functions. The range of the inner function, so the range of f in this case, must sit within the domain of g. Have a think about why that is the case. The range of f must sit within the domain of g. Well, if we look at it, f of x is the inner function, so that means the values we get as outputs for f of x are being substituted back in to g of x. So the values for the range, so the outputs, another sort of way of thinking about the range, the outputs of f of x must fit within the domain of g of x for the function, for the composite function to be defined. Let's check. The range of f, all right, the range of f is 1 to infinity. Does that fit within the domain of g? Yes. 1 to infinity sits within 0 to infinity. So that's our first check. You need to check that the function is defined. Now the next part is a bit more tricky. Here's the textbook definition of what the domain of the composite function is. It's probably worth writing down for your cheat sheet. So g of f, so g composite f, that's the same thing as g of f of x. Alright. And it has a domain that's equal to the domain of f, so the domain of the inner function, excluding any values of x, where the output of f of x, i.e. the output of f of x, the range of f of x, is not an element of the domain of g. So that's a very confusing way of saying the new domain, the domain of the composite function, is equal to the domain of the inner function, excluding any points or any values where the output of the inner function does not sit within the domain of the I'll say that again. So the domain of the new domain, the domain of the composite function, is equal to the domain of the inner function, excluding any points where the range of f, or the range of the inner function, is not an element of the domain of g. So we checked before that the range of f was an element of the domain of g. So that's all good. So the last thing we have to do is state our domain. So the domain of g of f of x, is going to be, well, it's just the domain of the inner function. excluding any values. Well, we don't excluding any values that we said here, but we didn't have any values that we needed to exclude because it sits with, because the range of f is a subset of the domain of G, so we don't need to exclude any values. So it's just the domain of the inner function. The domain of the inner function is R. Now, it's a hard question without a calculator. With a calculator, it would be dead easy. So if we look down here, this shows us the graph of g of f of x, and we can clearly see that it goes from, the domain is all real numbers, because it goes from negative infinity down here to positive infinity up here. Now let's smash through the next part. That's by far the hardest part of the question, I think. Definitely look in your textbook and research that to get a clear idea of that, because it will probably come up in exams and SACs. Find the rule of the derivative of g of f of x. All right, g of f of x, let's just quickly write it down. Equals log base e of x squared plus 1 or minus 1 plus 1. All right, chain rule. We know y equals log base e of u. So the y du is 1 on u. We know that from a formula sheet. Now, u is x squared plus 1. du dx equals 2x. Now, we know the chain rule says dy dx equals dy du times du dx. So that's equal to, we multiply these two things together, this and this. So that gives us 2x, and I might have done it in a different order, but don't stress about that, 1 on u. So that gives us 2x on u. Well, u, from we said before, is x squared on x squared. And my computer is not liking it, x squared plus 1. So there you go, we found a rule for the derivative of g of f of x. There we go, 2x on x squared plus 1. Hence find an antiderivative of x on x squared plus 1. Okay, this is integration by recognition. So we need to recognize that this function here we have we differentiated g of x to get this. So to go backwards, it would be like this. If we integrate that, that's going to get us back to what we had originally, which is g of f of x, which is log base e of x squared plus 1. Cool, so now we need to evaluate this and antiderivative. So when it says an antiderivative, we don't need to include the plus c, because we know that a derivative of a function can have many, infinite amount of antiderivatives. But when it says an antiderivative, you can give any option you like. So you don't need to have the plus c to make it general. You can give a specific case, because that would be an antiderivative. So we just need to take the 2 out. Leaves us with x on x squared plus 1 dx. Now you notice this is what we want. This is what we're trying to solve for. Equals log e, and my computer's slowing down, x squared plus 1. Alright, now to finalize it, we just say x on x squared plus 1 dx. Alright, we just need to divide through by 2 on both sides. So that's just the same as putting a half out the front. And there you have it. There's an antiderivative. So just back with this again. Definitely look in your textbook. Look up online. These tables can be helpful. You need to ensure that the range of the inner function is a subset of the domain of the outer function. That's one thing you need to drill into your mind. Okay. So make sure that's somewhere important. All right, good luck.